Hello again. In this video, I'm going to show you how to ask Geogebra to actually come up with a formula for your plotted function, plotted points. And it's actually quite simple. So we are just going to get rid of this keyboard for a while. And this is the opened file that you have saved before on Geogebra. So to ask the program to come up with the formula of the function for you, just by clicking a couple of things, we are just going to highlight the whole data and then go to this icon here in the corner, click that and choose two variable regression analysis. Once you do so, a new pop-up window will appear. And the only thing you have to do now is to go here to the regression model and choose, there are a couple of options there. We are going to ask a sine formula, sinusoidal formula. And once you click that, it actually just gives a formula right away for you. You see it? So I'm just going to take this formula and show you what's going on. Remember our general form that we have talked in class. It's always a times sine b and then x minus c plus d. So the formula we get from Geogebra is slightly different. So the first thing is the d is written here in front, but that's not a problem really. It's just a matter of rearranging. However, a slightly bigger problem is that here you have the bx and then minus something, but then b is actually inside the bracket, right? It's together with x here. So we should change this a little bit. I'm just going to copy this and just going to take the copied part here and I'm going to just rearrange it so that you can compare it with the general form. So I'm going to put the d behind here. So this is our d, that's an a, and b should be 0.02. So I'm just going to take it out of the bracket and write it this way. And you probably realize, oh, then this number should not be 1.32. Then it has to be something else. And that makes sense because remember, this number should actually show you how much the graph or the function is shifted to the right or to the left. It should show you the horizontal translation, right? And if we look at the number here, 1.32, and look at our graph, that doesn't really make sense because for a sine graph, then you probably have shifted this to the right, but certainly not by 1.32 unit. So what should we do? We need to think of a number here that should go in the bracket. It should be a number that when you multiply by 0.02, it should give you 1.32. That makes sense, right? Because when you expand this bracket, 0.02 times x is 0.02x, and then 0.02 times this second number, the second term, should give you 1.32 to be consistent and to not change any value in the previous formula. So not to worry, I'm just going to get my calculator, and here I just divide 1.32 divided by 0.02, which gives me 66. So 66 should be the number that when I multiply by 0.02 should give me 1.32. And if I look at my graph, that makes more sense. This means there is a horizontal translation 66 units to the right. Do you agree? So let's check, does that make sense? So a sine graph starts from the principal axis here, right? So normally there on the y-axis, it should actually be on the principal axis. And here you have translated that, you have shifted that to the right. And if we look at the position here, approximately at this point on the principal axis, then 66 unit makes more sense. So we are happy with our formula according to the general form that we have studied in class. So the only thing now to show you is this was actually an extra window. Yeah, so your previous plotted points is still there somewhere, and your data is also still there somewhere. So if you want to go back to the original screen, not to worry, don't panic. We just go here at this button and just click and say close. So you will go back to the original screen where you have your data and your plotted points. So try that, and good luck.